Alright, so in this video, I'm going to be solving the equation 25 to the power of x minus 5 to the power of x is equal to 20. So to solve this equation, I'm going to first start by subtracting 20 on both sides. So then these two cancel out, and I get 25 to the power of x minus 5 to the power of x minus 20 is equal to 0. Now 25 to the power of x, I can rewrite this as 5 squared to the power of x. So I have this minus 5 to the power of x minus 20 is equal to 0. And now from here, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And a to the power of m times n, I can rewrite as a to the power of n times m. So if a to the power of m times n is equal to a to the power of m to the power of n, then a to the power of n times m should equal a to the power of n to the power of m. So 5 to the power of 2 to the power of x is going to equal 5 to the power of x to the power of 2. Now I have this minus 5 to the power of x minus 20 is equal to 0. And now I'm going to let 5 to the power of x is equal to y, so I get y squared minus y minus 20 is equal to 0. Now, to solve this, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 20. So I get y equals negative 1 plus or minus the square root of b squared, so negative 1 squared, which is positive 1, minus 4 times a, which is 1, times c, which is negative 20, all over 2a, so 2 times 1. And this is equal to 1 plus or minus the square root of 1 plus 80 over 2, which is equal to 1 plus or minus the square root of 81 over 2. And the square root of 81 is equal to 9. So I get y is equal to 1 plus or minus 9 over 2. Now this gives me two solutions. I get y equals 1 plus 9 over 2, and y equals 1 minus 9 over 2. So 1 plus 9 is 10, and 10 divided by 2 is 5, so I get y equals 5 as one solution, and 1 minus 9 is negative 8. Negative 8 over 2 is negative 4, so y equals negative 4 is another solution. Now from here, remember how we let 5 to the power of x equal to y. So this means I get two solutions. 5 to the power of x is equal to 5, and 5 to the power of x is equal to negative 4. So let's look at this equation over here. 5 to the power of x equals negative 4. Well, we can't take the power of a positive number and turn it into a negative number, meaning this equation has no solution. And for 5 to the power of x equals 5, to solve this, what most people do is, for other exponential equations, we would have to take the log and do a bunch of other stuff. But as over here, we could just see 5 to the power of 1 is going to equal 5, because anything to the power of 1 is itself. So this is my solution. Alright, so in this video, I'm going to be solving the problem 2 to the power of 24 minus 1. So, for my solution, what I'm first going to do is rewrite this as 2 to the power of 12 times 2 minus 1. So all I did was I rewrote 24 as 12 times 2. And now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2, I can rewrite this as 2 to the power of 12 to the power of 2. And now 1, I'm going to rewrite that as 1 squared. So now I have 2 to the power of 12 to the power of 2 minus 1 squared. And now I can use the property that states that if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is 2 to the power of 12 and b is 1. So I get 2 to the power of 12 plus 1 times 2 to the power of 12 minus 1. Now from here, we need to find the value of 2 to the power of 12. Well, 2 to the power of 10 is equal to 1024. So this means that 2 to the power of 11 is equal to double of 1024, which is 2048. And 2 to the power of 12 is equal to double of 2048, which is 4096. So now I have 4096 plus 1 times 4096 minus 1. 4096 plus 1 is 4097, and 4096 minus 1 is 4095. Now, how would I solve this? Well, what most people would do is try to solve this by using the basic multiplication method, but this takes way too long. So a better way to solve this is actually to rewrite this as 4,000 plus 97 times 4,000 plus 95. Now, because 4,000 has so many zeros in it, it's much easier to solve this problem. So I'm going to be solving this problem by distributing. Or what I can also do, which is an easier method, is to rewrite 4,097 as 4,100 minus 3 times 4,100 minus 5. And this is also another way to rewrite this time subtraction instead of addition. But now, notice how we have 3 times 5, which is much easier to solve than 97 times 95. So now, I'm going to distribute my 4,100. So I get 4,100 squared minus 5 times 4,100. And then now I have minus 3 times 4,100 minus 3 times negative 5. So now, 4,100 squared is equal to 41 squared plus 4 zeros. 41 squared is 1,681, so I'm just going to add 4 zeros to the end there. And then minus 5 times 4,100, I can just say this is 5 times 41, which is 205, and then add 2 zeros. Minus 3 times 4,100, which is 123, and I can add 2 zeros. Minus 3 times negative 5, which is positive 15. So now from here, I get 16,810,000 minus 20,500 minus 12,300, which is equal to negative 32,800 plus 15. Now, a negative number plus a positive number is the same thing as 32,800 minus 15, which is 32,785. So now I have 16,810,000 minus 32,785, and this is equal to, I'm actually going to write this like this. So 10 minus 5 is 5, 9 minus 7 is 2, 9 minus 8 is 1, 9 minus 2 is 7, 10 minus 3 is 8, 8 minus 1 is 7, and I have 6 and 1. So 16,787,125 is my final answer to this problem.